Welcome to Click Academic. This is lesson 5 on the series Differential and Integral Calculus. We are going to be talking about continuity in this lesson. First of all, what is continuity? If we have a function, f of x, which has a limit, L. This is the limit of the function. The limit is L, for instance. Even though that does not really come into play yet. But let's assume we have a function f of x. At a point, x0. This is the point. So a function f of x is said to be continuous at x0 if it satisfies three conditions. The first being f of x0 is defined. It means if I substitute my x0 into f of x, if I substitute this value into f of x, the value I'm going to get is not an undefined value. I get a defined value. It might be 0, it might be negative, but I get a value for it. Next, my limit L exists. It means we can look at it several ways. We can say, okay, maybe my right hand limit is equal to my left hand limit, or my limit just plain exists. Let's leave it at that for now. Then the third condition is f of x0 is equals to my limit, meaning this value I get here is the same as this value I get when I calculate my limit. So I guess we look at a few examples to see how this pans out. So my first example is as a given f of x is equals to 3x squared minus x plus 5. I'm to show f of x is continuous at x0. My x0 now is 1. I'm to show that f of x is continuous at this point. So first we said f of x0 should be defined. So I look for it. F of 1 is equals to 3 times 1 squared minus 1 plus 5, which is just equal to 3 minus 1 plus 5, which is equals to 3 minus 1 is 2. This is 2 plus 5, 7. So my f of 1, my f of x0, which is 1, is 7. So my limit now, limit as x tends to 1, because my x0 is now 1, of f of x, which is 3x squared minus x plus 5, is just, we know in this case I'm not going to have an undefined value, so I substitute directly 1 plus 5, which as we have seen already is 7. So my limit exists. My limit is 7, my f of 1 is 7, and we said we should check. So my f of 1, f of x0, which is 1, is equals to 1, is equals to my limit as x tends to 1. My f of x0 is 7, sorry, is equals to my limit as x tends to 1 of f of x, which is the same as 7. So this is my third condition. Now it satisfies my third condition. So my f of x, which is equals to 3x squared minus x plus 5, is continuous at 1. That's x equals to 1, which is my x0. So this function is continuous at that point. So for my second example, I'm just going to pick another function. F of x is equal to x plus 1 divided by x minus 2. So I'm to show that this function is continuous at my x0 is 3 in this case. I'm to show that this function is continuous at 3. So my f of 3 first, it's 3 plus 1 divided by 3 minus 2, which is 4 divided by 1, which is just 4. This is my f of 3. So limit as x tends to 3 of f of x, which is x plus 1 divided by x minus 2. So if I substitute directly here, I can see also that I'm not going to get a division by 0. And we have already talked about avoiding that when we're solving for limits. So this is 3 plus 1 divided by 3 minus 2, meaning I've substituted my limits already. So this is just 4 divided by 1, which is 4. So for my final condition, it shows that f of 3 is equals to 4, which is the same as my limit as x tends to 3 of f of x. So this, my function f of x, is continuous at x0 is equals to 3. So this is how we solve continuity. Thank you.